Welcome to World Decoder. Today we explore the incredible world of titanium, uncovering why this extraordinary metal remains so incredibly expensive. Despite its staggering price tag, titanium is actually quite abundant in the Earth's crust, hiding beneath our feet in massive quantities. The real reason behind its astronomical cost lies not in scarcity, but within the extreme complexity of its highly demanding refinement. This remarkable material stubbornly clings to oxygen and other elements, refusing to exist in a pure metallic state within natural environments. Instead of pure veins, we find it locked tightly inside complex minerals like ilmenite and rutile scattered across various global landscapes. Extracting pure titanium from these stubborn ores requires a massive amount of energy, advanced technology, and incredibly precise chemical engineering processes. The ultimate enemy of this process is oxygen. If hot titanium touches air, it instantly reacts, completely ruining its structural integrity. Because of this extreme sensitivity, the entire manufacturing process must take place inside specialized vacuum chambers or under inert argon gas. To understand this magical transformation, we must dive deep into the famous Kroll process, the primary method for producing pure titanium. This complex industrial procedure involves multiple advanced chemical steps designed to carefully transform raw, dirty ore into gleaming, highly pure metallic material. The journey begins by mixing raw titanium ore with chlorine gas and carbon under intensely high temperatures inside massive industrial reactors. This intense thermal reaction creates a crucial intermediate substance known as titanium tetrachloride, which appears as a highly volatile fuming liquid. Converting the solid ore into this liquid state is absolutely necessary to efficiently separate out solid impurities and unwanted earthly materials. Once the liquid is purified, the next critical phase begins. We call this the reduction stage, where the real magic happens. The purified liquid titanium tetrachloride is carefully pumped into a sealed stainless steel reactor containing molten magnesium or highly reactive sodium. Inside this oxygen-free environment, a fierce chemical reaction strips away the chlorine atoms, finally leaving behind the precious pure titanium molecules. However, the resulting material does not look like a shiny metal yet. It forms a strange porous mass called titanium sponge. This bizarre metallic sponge gets its name from its highly porous, rough texture, looking exactly like a hard gray ocean sponge. The sponge still contains leftover magnesium and chlorine, which must be meticulously removed through a complex vacuum distillation process before proceeding. After cleaning, the titanium sponge is crushed into smaller pieces and pressed tightly together to form massive, heavy consumable metallic electrodes. These giant electrodes are then loaded into a vacuum arc remelting furnace, a machine capable of generating incredibly intense electrical heat. A powerful electric arc strikes the electrode, melting the titanium sponge drop by drop into a perfectly uniform solid metallic ingot. Sometimes this melting process is repeated multiple times or utilizes advanced electron beam technology to ensure absolute purity and structural perfection. Finally, we have a pure titanium ingot. But why go through all this extreme trouble and massive financial expense just for this? Titanium is universally recognized as a super material because it possesses a rare trio of properties that are extremely difficult to replace. First and foremost, it offers an incredible strength to weight ratio, sitting perfectly between lightweight aluminum and incredibly strong heavy steel. This unique balance means engineers can build structures that are exceptionally strong without adding unnecessary bulk or heavily compromising overall performance. Secondly, titanium boasts an almost magical resistance to corrosion, easily surviving harsh environments that would quickly destroy most other traditional metals. Even when exposed to highly acidic chemicals or salty ocean water, a microscopic oxide layer instantly forms, protecting the metal completely. The third remarkable property is its flawless biocompatibility. The human immune system completely ignores titanium, treating it as completely natural tissue. Because it does not trigger allergic reactions or toxic responses, it is the absolute perfect material for permanent surgical medical implants. While pure titanium is already amazing, metallurgists often mix it with other elements to create even more powerful and highly specialized alloys. By carefully blending in specific amounts of aluminum and vanadium, they significantly boost its overall tensile strength and extreme heat resistance. This specific titanium alloy is heavily utilized in manufacturing critical components for modern jet engines that operate under insanely high temperatures. Because of its incredibly high production costs, titanium is strictly reserved for specialized industries where catastrophic failure is absolutely not an option. The aerospace sector consumes a massive portion of the global titanium supply, relying on it to build advanced military and commercial aircraft. Using titanium in aircraft frames and jet engines drastically reduces the overall weight, which directly translates to significantly better fuel efficiency. In the demanding medical field, doctors rely heavily on titanium to manufacture durable artificial joints, bone zookays, and complex dental surgical implantae. Patients receiving these titanium implants can live normal, active lives for decades without worrying about metal degradation or severe bodily tissue rejection. Beyond aerospace and medicine, this premium metal has rapidly found its way into high-end consumer products and luxury daily lifestyle items. Premium watchmakers love using titanium for their luxury timepieces because it provides incredible durability while remaining surprisingly light on the human wrist. High-end eyeglass frames crafted from titanium offer unparalleled flexibility and strength, ensuring they can survive daily accidents without bending or snapping. Everyday carry enthusiasts highly prize titanium pocket knives and multi-tools for their sleek modern aesthetics and absolute rust prevention capabilities. Despite its growing popularity in consumer goods, the extremely high price of titanium still prevents it from completely replacing cheaper metallic alternatives. The scientific community is actively searching for revolutionary new methods to significantly reduce the staggering costs associated with traditional titanium industrial production. Researchers are currently experimenting with advanced electrolysis techniques, hoping to extract pure titanium directly from raw ore using powerful electrical energy currents. If these innovative electrochemical methods succeed, we could bypass the complex intermediate steps of the traditional Kroll process entirely and highly efficiently. Eliminating those difficult stages would drastically slash overall energy consumption and significantly lower the final market price of this incredible futuristic metal. A cheaper production method would finally unlock titanium for everyday applications, bringing its super properties to standard automobiles and common household appliances. Imagine a world where everyday cars are significantly lighter, safer, and never rust, all thanks to affordable mass-produced titanium alloy components. Until that revolutionary day arrives, titanium remains a premium investment material, offering maximum performance and unmatched longevity for those who eagerly pay. When you purchase a titanium product, you are paying for advanced science, extreme engineering, and a lifetime of guaranteed reliable physical durability. It is a material that clearly represents the absolute pinnacle of modern metallurgy, pushing the boundaries of what human engineers can accomplish. Let us take a moment to truly appreciate the massive industrial effort required to produce just one single block of pure titanium. From the deep earth to the blazing hot vacuum furnaces, every single step demands absolute precision and incredible scientific, technological, engineering mastery. Without this extraordinary metal, our modern space exploration programs and advanced aviation industries would simply not exist in their current advanced forms. Astronauts depend on titanium spacecraft components to survive the incredibly harsh, unforgiving vacuum of space and the scorching heat of atmospheric re-entry. Deep-sea explorers rely on titanium submarine hulls to withstand the crushing, immense pressure found at the absolute bottom of dark oceans. Even professional athletes benefit from titanium equipment, using ultralight bicycles and tennis rackets to push human physical performance to absolute maximums. The story of titanium is a powerful testament to human ingenuity, showcasing our relentless drive to master the natural, chemical, earthly elements. We took a stubborn, difficult mineral and transformed it into a shining symbol of advanced technology, medical miracles, and global aerospace dominance. Every time you see a commercial jet soaring high above the clouds, remember the hidden titanium skeleton keeping it safely, smoothly airborne. Every time someone walks again thanks to a new artificial hip, remember the incredible biological harmony made possible by this magical metal. The Kroll process, despite being incredibly expensive and energy intensive, remains one of the greatest industrial achievements of the 20th modern century. It allows us to harness a material that nature seemingly wanted to keep forever locked away inside useless common rocks and dirt. As we look toward the future, the demand for stronger, lighter, and more durable materials will only continue to grow rapidly, exponentially. Titanium will undoubtedly play a crucial role in building the next generation of sustainable transportation, renewable energy systems, and advanced space infrastructure. Engineers are already testing new 3D printing techniques using titanium powder to create incredibly complex, custom-designed parts with zero material waste. This additive manufacturing revolution could further optimize how we use this precious metal, making aerospace and medical components even more highly efficient. By melting titanium powder with precise lasers, we can build structures that are completely impossible to manufacture using traditional standard machining methods. The fusion of advanced digital manufacturing and titanium inherent super properties is opening up entirely new frontiers in modern complex mechanical design. We are standing on the edge of a new material era where titanium could soon become as common as high-grade steel. The ongoing quest to tame this metal perfectly reflects our broader human journey to constantly improve, innovate, and overcome seemingly impossible challenges. It teaches us that true value does not always come from extreme rarity, but from the immense effort required for chemical transformation. Titanium is not just a simple element on the periodic table. It is the fundamental building block of our bright modern future. From the depths of the Earth to the farthest reaches of outer space, its impact on human progress is truly absolutely immeasurable. The next time you hold a titanium object, feel its lightness, admire its strength, and remember the incredible journey it successfully undertook. You are holding a literal piece of scientific triumph. Forged in extreme heat, purified in vacuums, and perfected by brilliantly smart minds. Thank you for joining us on this fascinating deep dive into the complex science, history, and future of this truly amazing material. We hope you now have a profound appreciation for why titanium commands such a premium price in today's global industrial consumer market. If you enjoyed this detailed metallurgical journey, please make sure to subscribe and share this video with other highly curious science enthusiasts. This has been World Decoder, your ultimate guide to understanding the complex mechanics of our universe. See you in the next adventure.